This conference will now be recorded.
Today, let us start off with one more new topic and very important one, collections. So this will take totally 2 classes for us. The need of going for collections, let us understand. So by using arrays also we can collect the elements. So when you go with arrays, when we go with arrays, do we need to provide size here compulsory? When you are allocating memory for array, do we need to mention size compulsory? Yes, right? We have to compulsory give the size. If you are not giving size, it goes with error. If I go with the size as 50, means we can store maximum 50 elements only. We can what? We can store maximum 50 elements only. So if I want to decrease the size or increase the size, this is not possible. Okay, this is not possible. So means we cannot change the size during runtime. Once we have given the size, it is fixed. We cannot decrease or increase. But in reality, we cannot go for fixed sizes. That is a place where we go with collections. The main use of collections is collections are used to collect the elements of variable size, means not fixed. Okay. Now let us understand one of the very important interview question, arrays wise collections. What is the difference between arrays and collections? In arrays, we can collect the elements of fixed size, whereas in collections, we can collect the elements of variable size. It's not fixed. How many elements you want to collect, we can collect. This is the major difference. Okay. One more difference is like in arrays, we can collect only similar type of elements, whereas in collections, we can collect different type of elements. In collections, we can go with a different type of elements. One more important difference is in arrays, we can collect primitive type as well as reference type of elements. In arrays, we can collect what? Primitive type as well as even reference type of elements. Whereas in collections, we can collect only reference type of elements. Very important difference which we discuss on this more again. Collections only reference type. Now, so to understand more of collections, let us understand one of the important diagram, collections hierarchy. Collections hierarchy. All the collections, classes and interfaces are present in java.util package. All the collection classes and interfaces are present in which package? Java.util package. The topmost interfaces under collections hierarchy is there. One is collection and one more is map. One is collection and one more is what? Map. In the diagram, this symbol indicates interface. The symbol indicates what? Interface. So collection is an interface, map is an interface here. Now, When to think of collection and when to think of map. Collection is used only to collect the elements. Collection is used only to collect the elements, whereas map is used to collect elements in the form of key value pairs. Map is for what? Key value pairs. So the examples of key value pairs are like when you want to manage employee data like employee number, then the value of employee number. Like example, you can say employee number, the value of employee number. Employee name, the value of employee name. Salary, the value of salary, like this. So it will be in the form of key value pairs. Now, under collection, it goes with the two sub interfaces. One is list and one more is set. List, set. Okay, under this collection hierarchy, we are in two topmost interfaces. One is collection and one more is map. Collection is used only to collect elements. Map is to collect elements in the form of key value pairs. Under collection, we are in two sub interfaces. One is list and one more is set. When to think of list and when to think of set is, list is ordered. List is what here? Ordered. Whereas set is unordered. Set is what? Unordered. And list allow duplicate elements. In list we can store duplicates, but set does not allow duplicates. Does not allow duplicates. What is duplicate means? Same element repeating. We cannot repeat same element in the case of list. Sorry, in the case of list we can repeat the same element. In the case of set we cannot repeat the same element. Now, so like example, if you consider the elements like 5, 8, 6, 4, 7, the meaning of ordered in collection is the way we accept, the way we get. That's the meaning of ordered in collection. Unordered. The meaning of unordered is we don't know in which order it is going to take the elements. Whereas one more word, sorted. The meaning of sorted is either ascending order or descending order. Either ascending or descending is sorted. I'll document every word at the end. And what about duplicates? We'll discuss tomorrow. Under list, we are in two subclasses: array list and linked list. Under list, we are in two subclasses: array list and linked list. So when to think of array list and when to think of a linked list? Let us understand this. When to think of array list and when to think of linked list. So when you go with array list, in array list, the elements are stored in continuous memory locations. In array list, the elements are stored what? In continuous memory locations. Similar to arrays only, but the difference is arrays are fixed, whereas array list is variable size. How many elements you want to collect? We can collect. Now, here also it goes with index based. Here also it is index based. So let us suppose we are having some elements here like 10, 20, 30, 40 and 50. In this array list, we want to insert an element 25 in between 20 and 30, means in index 2. In index 2, we want to insert an element. Then the algorithm, the logic is we have to go to the last element and we have to shift the last element to the next location. Like that, we have to shift one element to the next location until you get where you want to insert. Means in the case of array list, when you want to insert an element or delete an element, we need to do the shift operations. We need to move the elements. Let us suppose in your list we are having 1000 elements and we want to insert an element at first, means we need to do near to 1000 shift operations. If you want to delete first element, again we need to do near to 1000 shift operations. So shift operations are time consuming. It takes more time to do this insert and delete. That is the reason when your application is having lot of insert and delete operations, don't go with array list. That's the final conclusion to remember. So then what we have to use? So when your application is having lot of insert and delete operations, then we have to go with linked list. So when to think of linked list? When your application is having lot of insert and delete operations. In the case of linked list, the elements are stored in non-continuous memory locations in the form of nodes. In the case of linked list, the elements are stored in what? Non-continuous memory locations in the form of nodes. A node is divided into two parts. A node is divided into two parts. The first part contains the element value. The first part contains the element value. And let us assume the element address of first node is some 100. The address of second node is some 200. The address of third node is some 300. Then in node, what is the next part contains? Address of the next node. Contains what? Address of the next node, and for last it goes with none. Means no element connected. Since the elements are linked with each other, that's the reason the name has come linked list. Let me repeat. What is linked list? It is a collection of elements stored in non-continuous memory locations in the form of nodes. In the form of nodes. A node is divided into two parts, element value and the link. Link contains address of the next node. Now, in this linked list, we want to insert an element 25 in between 20 and 30. Then what we have to do? Just we have to create a new node. Just to create a new node. Let us suppose the element is some 25 and let us assume the address is some 250. Then what we have to do? We have to replace this 300 with the 250. We have to replace 300 with 250 and 25 new element. Next part we have to replace with 300. So how the link will come now? From 20 to 25 and 25 to 30, and the link between 20 and 30 will break. So in the case of linked list, we are not doing shift operations, we are just changing the addresses. That is the reason when your application is having lot of insert and delete, we make use of linked list class over array list. So don't get confused how to write the program here. Nothing to write. Programs are all predefined things. So choosing the right class is important. I have elaborated. So I want to just elaborate the internal working of how array list is going to work and how linked list is going to work internally. But as a programmer, coding is simple. So just we use a predefined method add here. Just we use predefined method add 2 comma 25 means in index 2 it is going to insert the element 25. And when we use this add method with array list, it is going to do the shift operations. And same method in linked list also. Method remains same in linked list. But when we use add method with a linked list class, it is going to shift the addresses, change the addresses here. Right? Clear everyone? Any questions? The final conclusion, remember, simple. Just when your application is having lot of insert and delete, make use of linked list class over array list. That is the final thing to remember here. Nothing to worry how to write the codes. Codes are very simple. Coming to set. Set is unordered and no duplicate elements. Then under set, it goes with the subclasses like as set, sorted set, it's an interface. Asset, sorted set. There. Under asset, it goes with a subclass linked asset. In that sorted set, trace it. There. What is the uses? Asset is unordered and no duplicate elements. Now, let us suppose we are having a requirement where we want to maintain orderedness. Then we think of list, but we don't want all our duplicates, but list all our duplicates. So that is a place where we go for linked asset. So linked asset is ordered and no duplicates. And tree set is sorted. Tree set is what? Sorted. Okay. Coming to map. Map is used to collect elements in the form of key value pairs. Then under map, we are having subclasses like hash map, similar to set only. Hash map, sorted map, linked hash map, tree map. Same concept. Hash map is unordered based on keys. It is based on keys. Linked hash map is sorted based on keys. Sorry, linked hash map is ordered based on keys, and tree map is sorted based on keys. Right? Got it, everyone? Any questions? So choosing the right class based on the requirement, that is a major role of programmer here. Coding is simple, just we have to use the predefined methods here. Let me document all these words. So what are the document I'm typing? It's very important during interview times. The first one is collection wise. Collection is used only to collect the elements, whereas map is used to collect elements in the form of key value pairs. In the form of key value pairs. Like example, if you take collection, we do like this. It will be enclosed in square brackets and the elements are separated by comma. The elements are what? Separated by comma here. If you go with map, it will be in which format? Enclosed in between curly braces, and it will be in the form of key value pair, like employee number, the value of employee number, employee name, the value of employee name, salary, the value of salary, like this. It will be in the form of key value pair. Every key and value is separated by colon, and every key value pair is separated by comma. Next one, list wise set. List is ordered, whereas set is unordered. List allow duplicate elements, whereas set does not allow duplicate elements. In set, no duplicate elements. About duplicate, we'll discuss tomorrow. Like example, if you take the elements like 5, 8, 6, 4, 7, the meaning of ordered is like the way we accept, the way we get. That's meaning of ordered in collection. Unordered, in which we don't know which order it is going to take the elements. Sorted. Sorted means either ascending order or descending order. Next one. Array list wise linked list. Array list wise linked list. In array list, The elements are stored in continuous memory locations. Continuous memory locations. Whereas in linked list, the elements are stored in non-continuous memory locations. Non-continuous memory locations in the form of nodes. In the form of nodes. What is node? A node is divided into two parts: element value and link to the next node. One more important difference is in array list, or you can say the cost of insert and delete operations like this. In case of array list, the cost of insert and delete operations are more. Means it takes more time to do the insert and delete operations. Whereas in case of linked list, the cost of insert and delete operations are less. So when your application is having lot of insert and delete, then think of a linked list. Simple point to remember. Now, when to think of array list then? So array list occupies less memory than linked list. When your application is not having lot of insert and delete, then think of array list only. Only when your application is having lot of insert and delete, then only we think of linked list, else we go with array list only because it takes less memory. Next one, asset. Asset is unordered based on asset is unordered and no duplicate elements. Linked asset is ordered and no duplicate elements. Complete set, no duplicate elements. Reset is sorted and no duplicate elements. Next one, hash map. Hash map is unordered based on case. It is based on case and no duplicate case. Map also does not allow duplicates. Linked hash map. Linked hash map is ordered based on case and no duplicate case. Finally, tree map. Tree map is sorted based on case and no duplicate case. So this is very, very important, and we'll be seeing the example codes on all these classes also. Right? Any questions, anyone?